Hello, everybody. I hope you guys are doing well today. As an example, we are going to talk about an example in the work, but this example will take us a little bit further to look into how can we use work to find the energy of lifting a book. So this is a book about 5 kilograms, and we are going to lift it up at a constant velocity because that's very important. Constant velocity means no acceleration. And we are going to lift it up by a distance that is equal to zero point 0.2 meters. And in the same manner, we are going to put the book down at a constant velocity. Okay? So let's say a student is lifting this book up at a constant velocity to zero point 0.2 meters, then puts it down on the table, back again at a constant velocity. Okay, so we're gonna find work done. First of all, find work done to lift the object by the student. Okay, good. So work, we know, is equal to the required force multiplied by the distance and multiplied by cosine theta, where theta is the angle between the direction of the distance and the direction of the force, if we may say that. Okay, now what is the force that is the student is putting in lifting the book up? So we need to find this first, and we don't know exactly what it is. Remember, the student is lifting the book up at a constant velocity. So if they're lifting the book up at constant velocity, let's draw a free body diagram to find what the force is. So this is the book. The student's force is up and the gravity is down. So that's W, okay? Since we are moving up at a constant velocity, summation over the forces, which is equal in the y direction, mass times acceleration in the y dimension, but constant velocity acceleration is 0. This means all the forces must add up to 0, which means that F minus the weight is equal to 0, which means that F is equal to the weight of the object, and that's equal to mass times gravity. That is nice. Now, that's our F. So work, that's work, big W, is equal to the force, which is mg d cosine theta. Now, do we know everything? Let's check. The student is putting the force up, okay? So the student is carrying the book with his hand and pushing the book up with his hand. So the direction of the force, so I'm going to say here for this example, the direction of the force is up, and also the distance is up. See, look, the directions are in the same direction. For that, angle is equal to what? 0. So they're parallel. So angle is equal to 0. Cosine 0 is what? 1. That's nice. So W, which is the work done by the student to lift the book up, must be equal to 5, the mass of the book, times 9.8, times the distance, which is 0.2. And if we do a quick calculation, we are going to find that this is equal to 9.8 joules. Okay? All right. So that's the first part. Okay. Now let's do the second part. What does the second part do? The second part says, part B, find work done by the student putting the book down. All right. Okay, so we are going to write the work is equal to FD cosine theta. Same thing exactly, that's the equation for the work. Putting the book down, let's look now. This is exactly what we have. The student is still carrying the book with his hand. So where is the direction of the force of the student? Well, he's carrying the book with his hand, so the book is on his hand. So basically, if that's the hand of the student, Okay, and the book is sitting here, and the student is taking the book down. Where do you think the force direction is? The force of the hand is still up. Don't forget that. Otherwise, if the student is pushing the book down from the force above like that, he will slam the book down into the ground. But that's not happening. He's still carrying the book, but now he's lowering his hand. So that's the direction of what? The distance. He's lowering his hand down with a force that is also equal to the weight of the book because he's lowering at a constant velocity. So forces up must equal to forces down. Okay, that's a pretty good thing. So it's going to be mgd cosine theta. Okay. Now theta, what do you think theta is? The force is still up, so that's not true. So the force now is up. We agreed on that. The distance is down, so the angle theta is what? 180 degrees. Because if, look, that's the force direction, and that's the distance direction, and this angle here is 180 degrees. Okay, so I'm gonna plug in the numbers again. The book mass is 5, g is 9.8, and the distance is same distance, 0.2. Now cosine what? 180. Cosine 180 is -1. Okay, if we do this calculation again, we're going to get 9.8 joules, but with a minus sign. It's exactly the same. So these two answers are exactly the same. Exactly the same. However, one of them is opposite to the other. Remember, energy is a scalar quantity. Okay, you know what? Let's dig deeper into this example. How about this? Now we are going to find, okay, part C, we're going to find the work done by gravity, not by the student, as the book is being lifted up, okay, or carried up. Let's do that. Find Okay, remember, we are still moving the book up by the student at a constant velocity, but we need to find the work done by gravity at this time. All right, now let's try that. How do we do that? Okay, we need to find work done by gravity, so maybe W sub G is equal to work done by gravity. What's the work? It's force done by gravity times d times cosine theta. Okay, that's nice. What's the force of gravity? Well, we know that the force of gravity is mg. There's no debate about that. That's now the distance. Cosine theta. Okay, gravity is down, and the book. So that's gravity, which is W. But the book is being moved up, so what's the angle? It's 180 degrees. So I have to say here cosine 180. Cosine 180 is -1. And if I do the same calculations against the same number, but minus 9.8 joules. So on the way up, gravity did work that is minus 9.8 joule. But on the way up, the student did the same amount of work, but it's positive. The conclusion here is that when the student is lifting the book up, he is what? Doing this work, 9.8 joules, and it seems that the gravity is taking it from the student. Okay, now let's go to the fourth part. What do you think the fourth part is? Part D is that we need to find work done on the book by gravity on the way down. Okay, well, let's do that. Work done by gravity, which is the force of gravity times d times cosine theta. Again, the force of gravity is mg, and d comes down. Now, look, work done by gravity. The force of gravity is always down, okay? And the book is going down, so these are two parallels, so that's force done by gravity, or W, okay? And the distance is down, parallel coming down, so what do you think theta is? Theta is 0, so I'm going to put here cosine 0, and cosine 0 is 1, and if you calculate that, you're going to get 9.8 joules. Look what we have so far. 9.8, that's the student on the way up. The student on the way down, minus 9.8. Okay? Gravity on the way up, minus 9.8 joules. Gravity on the way down, 9.8 joules. So it seems that what the gravity got from the student is being delivered again. That's amazing. This example is very, very important because it tells us that in simple ways that energy is conserved. Energy is conserved. What you give is going to be given back to you. What you take, you have to give it back. Okay? All right. Remember this example very well. Thank you.